All right, everybody. What you're going to notice with this page and with these problems here is I got one math thing that we're going to do. One goal, one equation, one whatever you want to call it. We're a one-trick pony when it comes to Diffeqs today. The derivative plus number times function equals 0, initial condition. And you look at all these. Derivative, number, function equals 0, initial condition. Derivative, here it looks a little bit different. Don't let that fool you. Even here. So this is all the same kind of equation, even as we introduce things that start looking like physics. So we're going to go ahead and actually do this first equation. So the way that's going to look is x dot plus 3x equals 0. And to get the solution first, let's rewrite this in Leibniz notation. So dx dt equals 3x. And now we're going to go ahead and separate variables. I'm going to be super careful here, but I'm going to work quickly. So dx over 3 equals, and this is negative 3 when I subtract. I like that. I'm going to be super careful, but let me immediately make an algebra mistakes. All right, good. So in my mind, I'm imagining Lily rolling her eyes, Din chuckling, Aiden sitting indifferently, and Dylan putting his head on his desk. Obviously, I have a lot of faith in us. So dx over x equals, just kidding. I have a lot of faith in us. Okay, dx over x equals negative 3 dt. Yes, let's integrate both sides now. All right. You know what? I don't want to write it there. Let's start it here. So dx over x equals negative 3 dt. So separate out those variables, you turkeys. And then here we're going to say natural log of x equals negative 3t plus c. Now let's actually get our initial condition solved for. So we're told that x equals 0. X equals 0 equals 5. So what that means is natural log of, okay, x of 0 is 5. So at time equals 0, x equals 5. So that means negative 3 times 0 gives us c. I want to be clear. When I'm doing these Diffeqs, when I say natural log of x, that's really a shorthand, right? That's a shorthand for natural log of x as a function of time. Let's be careful about that, y'all. So when I say x is 0 is 5, when I'm putting 5 in for x, that's implying that time is 0. And so what I'm getting here is that c equals the natural log of 5. And now I can continue my solution here. So the natural log of x equals negative 3 times t plus the natural log of 5. Great. Now here, I'm going to subtract the natural log of 5 from both sides. So that's going to give me natural log of x minus natural log of 5 equals negative 3t. Now we're almost there. Look at this. Let's remember this rule. Natural log of a over b equals natural log of a minus natural log of b. So I'm going to use that fact here to get natural log of x over 5 equals negative 3t. I'm going to exponentiate both sides. So that gets me x over 5 equals e to the negative 3t. And so my solution ends up being x of t equals 5e to the negative 3t. That's our solution. If you're a little confused, let's go ahead and take a look at problem number 1. So we have dx dt equals 3x. Again, we're solving by separation of variables. So we're going to say dx over x equals 3 dt. And now we're going to integrate both sides. So we're going to get the natural log of x equals 3t plus c. Let's plug in our initial conditions to solve for c. So the natural log of x of 0 is 2. equals 3 times, again, we're at 0, plus c. So that tells us that c is the natural log of 2. And we're going to use that in our solution right here. So we're going to say that the natural log of x equals 3t plus the natural log of 2. Next, natural log of x minus the natural log of 2 equals 3t. So that's the natural log of x over 2 equals 3t. We're going to exponentiate both sides. And when we solve, we're going to get that x of t equals 2e to the 3t. That is our solution, and we are done. Again, if you plug this into the equation, you'll see that it works. And also, if you plug in 0 for t, x of 0 is, in fact, 2. Now here, for number 2, I just want to do one more example for you. Here, the variables are somewhat separated, but let's be careful. So we have 3 dv dt equals negative 2v. I'm going to be careful here. So I'm going to say dv dt equals negative 2/3 v. And that's going to give us dv dt equals negative 2/3 dt. So I'm going to integrate both sides here. And so, you know what? I did this wrong. This is dv dt equals negative 3v. Can't integrate it yet. So that's dv over v equals negative 2/3 dt. And so we're going to integrate both sides. So we'll get natural log of v equals negative 2/3 times t plus c. So that's the natural log of 4 equals c. So c is, in fact, ln of 4. Continuing here, we're going to say ln of v equals negative 2/3 t plus ln of 4. I'm going to skip a step here and say ln of v over 4 equals negative 2/3 t. We'll exponentiate both sides, and so we'll get that v of t equals 4e to the negative 2/3 t. Let's go ahead and see if you can do number 3 on your own, and then you should probably check the answer later. So I would pause the video and then resume play after you've tried to solve this. So go ahead and pause it, try to get the solution, and then check in now. Okay, so I'm assuming you paused and tried to solve. So we have dv dt equals negative 1/4 v. So we have dv over dt equals negative dt over 4. Dang it, I keep messing that up. Dv over v equals negative dt over 4. Sorry about that. Then we'll integrate both sides. So we're going to get natural log of v equals negative t over 4 plus c. So that's the natural log of 1 equals c. So c equals ln of 1. And that is going to simply give us that the natural log of v equals negative t over 4 when we plug in our initial conditions. So we're simply getting that v equals e to the negative t over 4 as our answer. All right. For number 4, I'm wondering if you can actually prove that in this case, v of t equals v naught e to the negative k over m times t. Can you prove this? That's kind of the last thing I want to leave you on in the videos. And so I'm going to wrap this up here and leave you to finish this up. And we'll talk about 5, 6, and 7 when I get back on Friday.